All right, boys and girls, a new lesson is here, and I think you're gonna like this one, well, a little bit better than the one yesterday. I think you'll find this is actually pretty easy with some organized thinking and some careful reading. It's really not too difficult, so hang in there. I'm gonna show you how these work, and we're gonna go step by step through every problem so you make sure that you understand. So here we go. Let's read the problem first, okay? It says, a soccer tournament assigns a unique, that means each team gets its own, so it assigns a unique two-color uniform to each team using the colors yellow, green, orange, and purple. Each uniform is mostly one color with a different colored stripe, okay? So that's important to know. So all uniforms are mostly one color with a different stripe. It says write an organized list using the format main color, comma, stripe color to represent the sample space. Use pencil and paper. Okay, we're just going to think our way through it. Okay, here we go. So if I'm looking at list A right here, if I go down this list right here, I see that I have yellow with a green stripe, yellow with an orange stripe, and yellow with the purple stripe. Now, are those all the stripes that yellow can have? Let's think. We have main color yellow, and then it could have green stripe, orange stripe, purple stripe. It can't have a yellow stripe because remember, it says each uniform is mostly one color with a different colored stripe. So those are all of the yellow possibilities. Check. Now let's look at green. We have green with yellow, green with orange, and green with purple. Remember, we can't go green with green because it has to have a different colored stripe. So all the greens are there. Then we have orange with yellow, orange with green, orange with purple. Those are all the possibilities for orange. And now look at the bottom. We have purple with yellow, and I couldn't scroll down and show you the rest of the choices. Let's see if you can think of what else needs to go at the end of this list A, because it is the right answer. We have purple, comma, something, and purple, comma, something else. We already have purple, yellow, so what else can we put right here? We could put purple, green, and purple, orange, right? So if those were at the bottom of that list, we would choose answer A, right? Be clearly the right choice. That's all of the possible combinations of uniform colors in choice A. You got that? Good job. All right, next question. Now just read carefully, and you'll find that if you read carefully, the problems are really not that hard. Okay, so let's read them together. It says, a designer has designed 2 pairs of pants, so pants 1 and pants 2, and 5 tops, so top 1, top 2, top 3, top 4, and top 5, to create outfits. Okay, that's the goal. It says use a tree diagram. That's, for example, what you see below in choices A, B, C, and D. Those are called tree diagrams. To display the sample space of possible outfits if she chooses pants and then a top for each one. How many different outfits could she create? That's the question we're trying to answer. Okay? So let's figure out which one is correct. Well, let's look at choice A. We have pants 1, pants 2, and pants 3. But wait a minute, are there 3 pairs of pants? No, there are only pants 1 and pants 2. So A is out. Let's look at choice B. There's pants 1 and pants 2, and then for each pair of pants, there's top 1, top 2, top 3, top 4, and top 5. And then for pants 2, there's top 1, top 2, top 3, top 4, and top 5. So B is looking pretty good. That looks perfect. Let's look at C. We have pants 1, pants 2, and pants 3. Again, we don't have 3 pairs of pants, so C is out. And then, look, D looks good because we have pants 1 and pants 2, but for each pair of pants, we only have 4 tops. But how many tops are there? There are 5, right? So each one of these pairs of pants has 4 tops. That's not a complete sample space. The only right choice is letter B. Do you guys see why? B is the right answer. I hope you're catching on to this. Let's do another one. Okay, here's another problem. It says 2 friends Each choose a slice of pizza with one topping. The toppings to choose from are tomatoes T, jalapenos J, onions O, and eggplant E. Write an organized list using the format, and this is important, friend 1, and meaning what friend 1 chooses on their pizza, and then comma, friend 2, meaning what friend 2 chooses on his or her pizza, to represent the sample space of topping combinations. Okay, so we want to know how many different combinations of single slices of pizza with one topping these two friends can come up with. Okay, so let's look. Let's look at choice A. We have tomato, friend 1 chooses tomatoes and friend 2 chooses tomatoes. And then they both choose jalapenos, they both choose onions, or they both choose eggplants. Well, you can see very clearly there's way more combinations than that, right? So let's look at choice B. Friend 1, tomatoes, friend 2, jalapenos. Friend 1, tomatoes, friend 2, onions. Friend 1, tomatoes, friend 2, eggplant. Okay, so it has friend 1 choosing tomatoes 3 times, and then choosing jalapenos 3 times, and then choosing onions 3 times, and then guess what? Choosing eggplant 3 times at the bottom, even though you can't see it. And that looks like a pretty good sample space, right? But you got to think clearly. Could friend 1 and friend 2 both choose the same thing? Yes. So you would have to have, in where friend 1 starts with a T, friend 2 could also choose tomatoes. Does that make sense, boys and girls? And so this sample space, as it's written in choice B, is good, but it's not complete. And so in this section right here, friend 1 could choose jalapenos, but so could friend 2, and that's what that's missing. And then friend 1 could choose onions, and so could friend 2. So choice C, you can see, is missing way too many combinations. It can't be C. And then look at choice D. Look, here's the missing one I said needed to be in the sample space, right? And then look, here's the missing one from that I said needed to be in choice, and then onions is down below. So you can see though that friend 1 could choose 4 tomatoes, right? And friend 2 could choose 4 different toppings. And then friend 1 could choose jalapenos, and friend 2 could choose 1, 2, 3, 4 different toppings. So choice D is the correct sample space. That shows every combination of friend 1 and friend 2 choosing their pizzas. Let's do another one. Okay, remember, just read carefully. That's the first step. It says use a table to show the sample space of 2-digit numbers using the digits 1, 4, 5, and 9. So let's see if we can do this. It says use the column label, use the column label as the tens digit. So we're going to have a 2-digit number. We're going to fill in the spaces. This is the tens digit, right? And this is the ones digit. This is the tens. This is the ones. My pen, I wish would work. Oh, so annoying. Oh my gosh. There. So we're going to have the tens and the ones. So the tens come from the columns, and the ones come from the rows. That means that this is too small. So let me try and blow this up a little bit. This would have to be the number, hang on, 14. This would have to be, oh, no, sorry. This would have to be the number 11. This would be the number 14. This would be the number 15. And this would be the number 19. This would be the number 41, 44, 45, and 49. Now I bet you can figure out how to fill in the rest of that. Good job, boys and girls. I think you understand this one. Just quickly, though, let's go over it together. It would be 51 right here, 51 54, 55, 59, and then 91, 94, 95, and 99, right? You got it. Okay, almost done. Let's read carefully. A museum gift shop sells hats with embroidered logos. The hats are available in small, medium, and large. They are available in the colors red and green. Make a tree diagram to represent all possible varieties of hats sold at the museum. So we're going to make a tree diagram. And these all show tree diagrams. Let's find out which one is right. Well, just looking it over, you can see that choice D is the only one that lists small, medium, and large hat sizes, and shows that there is red and green for the small, red and green for the medium, and red and green for the large. So this is a complete sample space, and there are 6 total possible outcomes. Just in case that question came up, if the test or the assignment asks you, you always look at the very last part of a tree diagram to add up all of the possible combinations. So in other words, you could have a small red hat and a small green hat, a medium red hat or a medium green hat, a large red hat, and a large green hat. That's 6 total possible combinations. All right, let's do one more, or maybe 2 more. Okay, boys and girls, it says a table with 3 rows and 5 columns can represent the sample space of combinations of a number between 1 and 3, followed by a letter between A and E in the English alphabet. So you have the numbers 1, 2, 3, and you have the letters A, B, C, D, E. You want to combine them in as many ways as possible. So, if I blow this up so we can do this, let's see what we can write down here. We can write down, this is 1A, this is 1B, I think you get the hang of this, don't you? This is 1D, and this is 1E. What's this one down here? 2, oh my pen, please work. 2A, 2B, 2C, 2D, and 2E. And finally, 3A, 3B, 3C, 3D, and 3E. I think you understand how to do this, boys and girls. Now there's one more question in this problem. It says, what other way could we organize the table? And the idea is that we could put, if we drew it, we could put, if I make the table really quickly, we have right here and right here. We could have 1, 2, 3, 4. We could put A, B, C, D, and E in the rows, and we could put the numbers 1, 2, and 3 across the columns, and then we could fill in the sample space, but we're going to end up with the same answers. This is going to be 1A, 2A, 3A, 1B, 2B, 3B, right? And we'll end up with how many total possibles? There are 15 possible outcomes in this table, and look at how many blank spaces are in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Same total possible outcomes. So it's just a different way of organizing the table. I think you got this, boys and girls. Let's go get them. Do your assignment. You got this.